In this chapter, we're going to be studying some descriptive measures that can be made on a set of data. Now, the set could be a sample, or it could be a population for the set of data. Now, those descriptive measures have to do with measures of central tendency about the data set and measures about dispersion, or the amount of variation that occurs in the data set. We're going to begin with the notion of central tendency. Now, measures of central tendency are simply averages, and you are already familiar with an average, but the kind of average that you're probably familiar with is the arithmetic mean. We'll just be referring to it as the mean. There are other averages. There are other words that are referred to when we talk about the word average. One of them is the word mode. Now, you see the three words here, mode, median, and mean. The word mode refers to model, or that's a key word that'll trip start your memory about what mode is all about. It's the one that occurs most often in the data set. Now, if there are no items that occur most often in a data set, then there is no mode. We'll look at an example in just a moment. The median is simply the middle item in a data set, and this may be an item that is in the data set itself, or it may be an item that we have to calculate. Again, we'll look at an example in just a moment, but the operative word for median is simply middle, and it's a notion that there are just as many data values above this middle number, or this median, as there are below it in the data set. The mean is what we generally refer to as an average. It's the arithmetic mean. It's taking all of the, the sum of all of the data entries and dividing by the number of data entries. And you've calculated this many times probably in the past. If you want your average in a math class, then you take all of your grades for a term or whatever period of time you'd like, and you add all of those grades, and then you divide by the number of grades that you have. So that is your average. That is the mean that you're calculating. Now, this is called the, technically, it should be called the arithmetic mean to differentiate it from other kinds of means. There is a geometric mean. There is a Huronian mean, all in mathematics. So technically, it should be the arithmetic mean, but often we'll just refer to it as the mean. And if in the future where we say the word average, we're talking about mean. If we want to specifically talk about median and mode, we will say median and mode. Okay, so the idea with the mean, if we're taking the sum of all of the entries in a set of data, then we're using all of the values in the set. And that's one of the advantages, well actually that's one of the both advantages and disadvantages in using the mean. You see, the mean uses all of the data values, but because it uses all of the data values, there could be an extreme value that comes into play, and that's the disadvantage of using the mean. Well, let's talk about an example that uses the mean, median, and mode. Let's talk about this set over here. Here's just a group of small numbers, and we're not going to say whether this is a sample or a population. It really doesn't make too much difference. But it's 8, 2, 7, 1, 2, 9, 8, 2, 10, 9. Okay, and these are in relative random order. The first thing to do when you have a set of information like this is to put the numbers in order. So I have rewritten them here. The smallest item in this group would be 1, and then there are 3 2s, and I have written the 3 2s, and then so on all the way down to 10. And now it's pretty easy for us to identify mean, median, and then to calculate the the mode, the median, and then to calculate the mean. The mode, the model item, the item that occurs most frequently, is the 2, because the 2 is occurring 3 times here, and there is no other value that occurs that many times or more than that many times. Now, so the mode is 2. Now, the mode is the least stable, perhaps, of all of these measures. And it is least stable because with one change we could have a different mode. For example, if we took out one of these 2's and added a 9, then the mode would be 9, you see. So it's not a very stable measure. the median, the middle item. Now, the key idea with calculating median is that we're calculating a number such that there are just as many data values above that number as below that number. And so when we look at a set of information like this and counting the number of items, we would count 10. Well, if there are 10 items, then it makes sense that we would want to have 5 items above the median and 5 items below. Now, in order to have 5 items above and below, then the median would have to be, let's see, here's 1, 2, 3, 4. Here's the 5th item. Here's the 6th item, so the median has to be right in between. Now, if there were 11 items, then the median would be one of the items in the data set. If there were 11, because it could be the 6th item, because from the 6th item, if they're in order now, the 6th one would have 5 items both above and below, so it would be an item in the data set. Here, it is not an item, it is not a value in the data set, it's in between 7 and 8. So we actually have to take the mean of 7 and 8. So we're adding 7 plus 8. Right in between 7 and 8 is 7.5 or 7.5. So to find this median, then here's what we're doing. The calculation is 7 plus 8 over 2, and that turns out to be 7.5. Okay. Now, for the mean, it's the sum of all of the data entries divided by the number of data entries. When we add these, and I'm adding here, we would get 58. And there are 10 items, so to find the mean, it's 58 divided by 10, or 5.8. Now, I mentioned the downside of the mean, and that is that it can be affected by extreme values. And let me show you an example of that now. Suppose that the top item, instead of being 10, turns out to be, let's just make it 1,000. And then adding here, we would get 1,048. And calculating the mean, then, we would have 1,048 divided by 10, or 104.8. Now, is 104.8, is that number descriptive of the central tendency for this group of numbers? Well, certainly not. It's this extreme value that threw off the mean. Now sometimes, and that's the disadvantage of using the mean, that an extreme value can throw it off. To accommodate this extreme value throwing off the calculation of the mean, sometimes we can trim the data set and then calculate a mean, and sometimes it's a little more meaningful. For example, we could take the data set and we could trim it by a certain percent on both ends, both above and below, and therefore hopefully take out extreme values. For example, here we could calculate a 10% trimmed mean. Now what that means is that we're taking 10% of the values in the data set off of both ends. Now 10% of 10 items is 1. 10% of 10 is 1. So we're going to take one item off of the top and the bottom. So we would take off this 1. Let's eliminate the 1. Eliminate the 1,000. And now the sum turns out to be 47. So the calculation of the mean then would be 47 divided by, now instead of 10 data values we only have 8, so it's 47 over 8, which turns out to be 5.875. Now notice that this mean is not exactly the same as the 5.8 that we calculated earlier with the entire data set before the extreme value was put in, but it's very, very close, and certainly it's a whale of a lot better than the mean that we calculated when the extreme value was involved. Well, let's talk about mean, median, and mode and how they apply to different kinds of sets. We could be talking about a sample mean, you see. We could be talking about a population or a population mean. And the notation is just a little bit different for those two. If we're talking about a sample mean, then the notation for the mean is x bar. This is read x. It's an x with a little bar above it, so it's read x bar. And this symbolism, this notation means the sum of x values, the sum of the entries in the data set, you see, and n is the number of entries in the data set. So summation here for this symbol. So sum of x values over n number of values for x bar. The population mean is, the notation is mu. And mu, it's the same idea, exactly the same calculation, because we're taking all of the data entries and we're dividing by the number of entries, and sum of x values is exactly the same as it was before, but here we use an uppercase n to indicate that this is the number of items that are in the entire population. A subtle difference for us now. We'll learn more about the differences between these two as we go along. Let's take a look at how we might use the graphing calculator to calculate the mean and the median. It's really very easy. Press the Stat button, and here's the menu that shows up. We want item number 1, so we'll either press number 1 or Enter because we are editing. Now we see a group of columns that show up, and we can go into any of these columns if we want to, but in this first column, this is L1 or list number 1, I'm going to enter the items that we had on the board earlier, and I'm going to enter them in no particular order. At the beginning of our discussion of the 10 items, we had the items listed sort of randomly, and I'll enter them that way. 8 was the first item, and then 2. And as I press the numbers, I am pressing Enter at the bottom of the calculator. So I just pressed an Enter, and the 2 shows up. Then 7, Enter, 1, Enter, 2, Enter, and away I go. 9, 8, 2, 10, and then 9, Enter. Now once all of the entries are made, we want to go back to the Stat menu. I'm pressing the Stat button now, and we want to calculate. So I'm cursoring to the right, and the calculation I want to make is for one variable stats, and that's the top item that we see on the list. So I'll press Enter or number 1, and this is what shows up on the main screen. Pressing again, and we get a lot of information. Now some of this information we have seen before or we are familiar with now, and some of it we're not. It turns out that the top item, the x bar, is our mean that we're looking to calculate here. And so here's the x bar of 5.8. This sigma notation with x means the sum of x values. We'll have a lot more to say about summation notation in a little bit, but we did make this calculation on the board because we had to add the entries together, and this is that sum. Let me cursor down a bit more. I think there are some things here that would be of interest to us. N, the number of items, is 10. We had to use that in the calculation of the mean. The minimum x value was 1. The maximum x value down here is 10. The median, 7.5. So the calculator is calculating a lot of information, and much of it is information that we've already looked at. So the calculation of mean and median is quite easy using the graphing calculator. Sometimes in calculating an average, we would like to assign a little greater weight or importance to one data value or another. For example, if a teacher is assigning a grade for a course based upon a midterm test and a final exam, and the teacher wants to, let's say, assign a bit more importance or weight to the final than to the midterm, that gives us an occasion to calculate a weighted average. Now here's the situation. Let's say that the midterm is to be worth 40% of the grade and the final exam 60% of the grade. Now each test is worth 100 points, and a 90 is needed for an A. Now let's suppose that your scores are for the midterm 85 and the final exam 94. Now a regular arithmetic mean here would mean that we would add 85, 94 and divide by 2. It gives us an average of 89.5. Well, the weighted average, though, is a bit different than that, and let's make the calculation over here. Now, let's say that the test scores, here are the test scores, and this is one way to lay it out, and there are a lot of good ways to do it, but here's one way, and these are, we'll call these X values, but the test scores are 85 and 94. But we have to factor in the idea of the weight, and the weight for this test score is 40%, and for the final exam, 60%. Now we're going to need to calculate an X times W in this process, and I've created a third column for an XW. So 85 times 40% is 34, 94 times 60% is 56.4. Now the notation for the calculation is like this. Now I want to compare this with the X bar notation. The X bar notation is the sum of X values divided by the number of values that we have. But here, the weighted average is simply the sum of items that are of the form X times W, a data value times its weight. And in the denominator, it's the sum of the weights. You see, the sum of the percents, if you will, that are in this calculation. And let's see, the XW, the sum of XWs, well, the XWs are 85, the midterm, times its weight, plus the final exam score times its weight. And the sum of the weights would be 40% plus 60%. This turns out to be 100% or simply 1. And this calculation in the denominator will often be 1, but may not always be so. So we need to put these in here. But at any rate, in the numerator, we have 34 and 56.4, the values that we had up above, and we find then that the weighted average is 90.4. So an A has been achieved in this course.